Well,
Yes.
good evening, everybody, and welcome to yet another edition of Takeo After Dark. I'm John Barba with Dave Holdorf and Rick Mayo and Tim Ward from Mechanical Hub. Welcome, everybody, to what promises to be a great penultimate episode of Takeo After Dark, the winter season. Look it up. It's a good word. We're really excited to be here. We've got a great 2 weeks for you on low temperature hydronics. Tonight, we're going to talk about arranging the emitters, and next week we're going to dive into some pretty cool stuff, some new stuff that maybe you've never seen from Takeo before, as well as just options for low temperature hydronics. But we're really happy to be there. And Dave, did you hit share your screen so we can see that? Because I'm just seeing our four ugly pusses. I think I'd rather see the presentation.
Let's get through the four of us at first before I pull up the screen. So and
Okay.
I know Mr. Ward probably has a couple of words to say before we get started too, so we're good.
Right. While we were on deck here, we've been waiting to start with the four of us on screen. I'm just looking at Rick, Tim, and Dave, and I see my future. That's all I got to say.
It's a good future. It's a good future.
Tim from, and we are all ugly. Yes, Richard. Thank you. Yeah. Didn't used to be though, man, in the day. I'll tell you what. Hey, Tim, as our host, as our sponsor and co-host with Mechanical Hub, could you share with the group a little bit about what Mechanical Hub is and what you guys are up to this week?
Sure. As many have heard over the last couple of years as we've been doing this, we are a digital asset for the industry, websites, newsletters, and social media platforms. I want to give a shout out to my partner in crime, John Mason-Brink. He's been busting his backside for some industry forecasts. He's put a couple up on the website, mechanicalhub.com, last couple of weeks, talking to many of the manufacturers in the industry about 2022 and beyond, and the forecasts are really good insight at what many in the industry are doing. In fact, I believe next week will be the Takeo industry forecast. So I'm looking forward to that. And we also, our latest podcast dropped today, early this morning, we interviewed David Hessen from Hessen Plumbing in Ohio. Great guy, loves plumbing, loves trades, and he loves his Harley. So if you get a chance, you're got 30 minutes, go listen to the podcast with David Hessen. John and I interviewing him.
Awesome. Well, great. Hey, and thank you so much for being a co-sponsor of Takeo After Dark we're coming up on our second anniversary, I think, right about now. We've been doing this for 2 years now, and it shows no sign of slowing down, and it's become a Wednesday night tradition for us. So we're so thankful for you guys to helping us put this out there. Tonight is another Bruce Campbell approved presentation, and this will be Dave Holdorf leading us through the basics, the fundamentals of low temperature hydronics, dealing with heat emitters, and how we don't, when we have hydronic heat emitters, we don't have to have 180 degree water. We don't even have to have 140 degree water. If we're smart and if we do the math, even in retrofit applications, we have opportunities to look to low temperature hydronics. So with that, I'm going to turn it right over to Dave, give everybody out there a break. I'm going to shut up for the next hour and let Dave take over the con. I know that's everybody's favorite thing. Everybody likes Dave, and that's fine. So Dave, take her away and lead us down the path of low temperature hydronics, if you would.
Excellent. Thank you, JB. Greatly appreciate it. And also, of course, to Mr. Bruce Campbell here, too. So had to find a nice new picture of Bruce, and I thought this was fitting for tonight. So let me just get a couple of settings here changed. There we go. Don't need to look at that. And make that go away. All righty. So low temperature hydronic applications tonight. So let's get started with it. So for those of you that may be new here tonight, what is it, Takeo After Dark? Well, Takeo After Dark is our weekly nighttime sessions for training classes. And the winter session that we've been working on is a 5-week session. Now, we haven't had where you needed to go to week 1 in order to understand what was happening in week 2, and so on and so forth. However, and same thing, with even next week, even though it is a kind of a 2-part that kind of blend into each other, they are still 2 different independent classes. So that's our 5-week session. And if you only registered for tonight and you want to make sure you get to next week, we do individual registrations for the classes. So this way you get a link to the recording if you missed it or missed something, or you just miss us and you want to watch us again. So you'll get that email 23 hours from now. No, I'm sorry, 24 hours from now. You'll get an email with the link to the recording, and then you'll also get a link to register for next week's class. And for those of you that are looking for your PDHs, your certificates of attendance, that will also be included in that email. We also like to do prizes. I got stuff to give away in the basement, mostly Take-O After Dark t-shirts like John was wearing before. So if he puts his camera back on, you'll see some of the apparel. And I've got other accessories in the basement. There it is. That's right. Nice Take-O After Dark on the front, Take-O After Dark on the back with the Take-O logo on the sleeve for giveaways. So we have a whole bunch of things that we'll be giving away, and we'll raffle off based, some on participation and also some on some just basic trivia that we like to do and have a little bit of fun, because there's nothing like going to a training class that is just boring as can be. So we make it, we're going to make it some fun, and we're going to do some learning tonight too at the same time. So if you're out there on social media with us and Mechanical Hub, obviously those guys are huge out there, so also pay attention to them. But with Instagram, John and I do a Monday night live. Now, we haven't done it in a little bit. We've taken a little bit of a winter break. A lot of people out there working hard. But what you want to do is take a look at and follow the Take-O Comfort page. And at 7 o'clock on Mondays, John and I are live, and more or less office hours, tech support. When football season was going, we did a little bit of a tailgating party beforehand. So that's usually on Mondays, 7 o'clock Eastern time. So follow Take-O Comfort, you'll get the warning or the alarm that we're actually on live. At the same time, if you want to follow any one of us, Take-O Comfort for Instagram. Myself is at Take-O Training, and Mr. John is at J Barber Take-O Trainer on Instagram. So please take a look and follow us there. And of course, the company itself being on Facebook, YouTube, and everything else that's out there social media wise. So take a look for us and make sure you get notified of all the things that we're involved in and what we're up to, especially, something like this, when you see that, some new product introductions. Obviously, we're going to flood that a lot on the social media pages. Again, so for some of you that are new to webinars and Take-O After Dark with us and go to webinar, maybe you're not too new to webinars. There's been a lot of Zoom calls and all that other stuff out there. So, but if you're new to go to webinar, just a couple of ways to work around and navigate around. If you only see this orange arrow that you see in the screen at the top left-hand corner, it's pointing to the left, click on it and it will expand out to as you see here on the screen. And it'll look similar to this. So you'll see the audio section. So you're having issues or challenges hearing us, that's where you're going to choose your speakers to come from. If there's any handouts, that's where we're going to see them. And there are 2 handouts tonight. So you can take a look at those. And most important is the questions chat section. It looks like a question mark, or you'll see questions tab and a white box. Make sure you type something in there. And of course, at the end, you have to click on send. So just to make sure that everybody can hear us and see the presentation, if you can just quickly say, yes, all good. Hi, hello, how are you? Make sure that the communication is working there, because there's nothing like when John and I and Rick are doing classes and we're talking to ourselves and nobody can hear us. And yes, I see a whole bunch coming in there. Greatly appreciate that. And there will be periods when I want you to answer a question. It might be silly, it might be simple, but answer it just so we know that you're all online with us too, and we haven't lost an internet connection. So actually earlier today, I reset everything, powered down, powered up, so I'm all good with my IPs, and so I should be as fast as I can be here tonight. So awesome.
You just jinxed yourself, Dave.
I'm sorry, what's that?
You just jinxed yourself.
I know. So if you're watching, go to webinar tonight, watching us on a device like your phone or a tablet, things look a little bit different. And here's what we're looking at, say, on an Apple device. You'll see the screen at the bottom left-hand side, and that you'll toggle between our webcams and the presentation. So you won't be able to see both of us at the same time. And then there's your audio sections, and then there's your question section to ask or answer anything to us. So always answer or ask any questions during the presentation also, because we don't do a question and answer period. You have a question, type it on in there. We will get to it. And, you know, John and Rick may interrupt me periodically, and I will also ask them to monitor those questions. So that's why we will take those breaks every once in a while to make sure we answer your questions. And then, of course, at the end of the presentation, if we didn't get to your questions, we will stay on as long as you want us to. There have been times that we've been online for about 3 hours. So just talking away on different topics and conversations. So please stay online and type those questions in for us, because that's what we love. I think I love that part at the end of the evenings. All right, so tonight's theme, of course, if those of you that may be new, we like to have a little bit of theme every week or so. And tonight's theme, I'm sticking with the 80s TV shows, and had to go after Cheers, of course, for Takeover After Dark, right? I mean, how do we not even think about this last year sometime? So, and the cast of characters tonight, there we go. You got to pull them in, the 3 famous ones for the show, right? There it is, Norm. And John pulling off Sam because you got to make sure he's the New England guy, and Rick, the guy that knows everything. And yeah, I was trying to find a jacket and tie like Norm normally wears. I didn't have anything in the closet that would match up, so I stayed in the Takeover After Dark tonight. So
I gotta tell you, Dave, I was looking for my Red Sox jersey. I can't find it anywhere. So
oh no,
I know
that's not good, brother.
I know. I have to go shopping now. Carry on.
All righty, so that's our cast of characters tonight. We'll carry that on through tonight. So let's get to work. And there's your jacket, John, on some low temp hydronic applications tonight. All right. So before we get started in talking about the low temp applications, it's all about the heat loss. And if you've been to any of our Takeover After Dark classes, you know that we always start with that foundation and have to do the heat loss first. And otherwise, we're just guessing and we have no idea what's going on. So we always need to start off with that heat loss. And so we're not going to do the heat loss tonight. If you need to review it, we usually do it in part 1 of the factory class of Takeover After Dark. So if you need to go back, take a look at the YouTube page, go find that on how to do the heat loss. But our today's example, working throughout the entire presentation, is looking at a 10 by 15 room, 9-foot ceilings, 2 outside walls with a couple of windows. All right, and when we do that heat loss, we're looking at those numbers coming in here, and we see this room needs 3,216 BTUs per hour. So we're going to work with that number all day today, all evening tonight. We're not going to worry about the rest of the house, but if you wanted to, let's do the heat loss there. Bang, there you're done. And the total load of the house of 43,116. All right, but we're going to work off of this room, 10 by 15 room, and a lot of different applications, a lot of different heating sources or heat emitters that we're going to put into this room, and see what we can get out of it, and how we can work with either 1, what's there, or 2, how to make it as efficient and as comfortable as possible at the same time. So, so how much radiation is needed in a room of that size and that heat loss itself? So the 3,216 BTUs per hour, and let's go take a look at what would be the most common heating element that we're going to throw into a lot of these homes, which is going to be fin tube baseboard. And these are the pressure, these are the heat output charts that we see from Slant Fin. All right, so the Slant Fin charts, and you know what, every manufacturer has different charts that are out there. Make sure you pay attention to them, and make sure you also understand these charts. And what would the one thing that we're looking at today is looking at the 1 gallon per minute column, the row here. All right, this is what we want to pay attention to. The 1 column a minute, 1 gallon per minute. When you read in here, if you, it says use 4 gallon per minute ratings only when the flow is known to be equal to or greater than 4. Otherwise, use the 1 gallons. So if you actually knew exactly you had 4 gallons a minute in your loop, then you could use that row here. So we're going to use the 1 gallon a minute row. So let's take that number based upon what water temperature you have in the system, and there's your BTU output per linear foot. So if you did that heat loss on the structure here, seeing 180 degrees as your supply water temp, you're going to get 580 BTUs per linear foot. So what you end up doing, let's take that quick example. 10 by 15 room, we had the 3216 divided by 580 BTUs per linear foot. So you do that division and you come up with that you only need 5.5 foot of element, all right, to go into a 10 by 15 room here. All right, now not many people are going to do 5.5 feet of element on this exterior wall. All right, it just doesn't look right. I know you know what, down in a lot of the projects like my house here, before I renovated the place, it was any outside wall with a window, you filled it. All right, so yes, my house, if this was my room here, this would have had 25 feet of baseboard running here when it only needed 5.5 feet, right? So today's class is now, let's get that water temperature down lower. And if you happen to have 5.5 feet in here, all right, that's what it is. But let's say we're going to have something a little bit oversized in here, as like, say, my house, not necessarily wrapping the entire house, all right, but maybe we've got, say, 10 foot installed. All right, so with 10 feet of element installed, now I want to know what water temperature do we need to supply this room to heat it adequately. And yes, we're just doing one room here. So if you were to do a whole house, or you're looking at doing some renovation into this house with the boiler room, go back and do the heat loss. And then come in and take a look at how much element is there, so we can determine what would be the maximum water temperature that you need. So for this example, we're going to say, hey, we've got 10 feet in there. We did the math and said we only need 5.5 feet, 10's installed. So, and some people turn around and say, wait a minute, a lower temperature than 180 degrees for baseboard? It works. All right, it definitely does. And if you come along and you take a look at these charts again from Slant Fin, all right, they have these numbers going from 220 degrees down to 150 in white. And then all of a sudden they get down to this 140 to 110 degree as your supply design, right? And so what we've got here is, one, you've got this section here yellowed out and grayed out there, and it's got some stars behind it saying, hey, one, if you're going to design around here, these are ideal for your modulating condensing boilers. All right, when you start looking at your ModCon boilers, we like to see a low starting temperature and also a low return temperature. That means it's going to get what the warm and fuzzy brochure says it's going to get. All right, that warm and fuzzy brochure on the boiler said on the front side, that made it so attractive to the homeowners, was 97% efficient on the front side of it. All right, that's what they were attracted to. But if you operated at 180 degrees, you didn't get that 97% because the boiler wasn't condensing. You're sending out 180 and it's coming back at 160. These boilers start condensing with return temperatures of 135 degrees and lower. All right, so it's not even thinking about condensing at this point. Exactly, up to 97% efficiency. There's a ... It depends. You flip over the sheet. You know, the warm and fuzzy says one side, you flip it over, and then it gets into the technical details, right? So nobody reads the technical details. We just like the warm and fuzzy stuff on the front side of it. So this area is really your goal in getting down and making sure that that boiler is going to condense. All right, so let's take a look at the math. So we had our heat loss of 3,216 BTUs, 10 feet installed. We only needed 5.5. So you take your heat loss, 3,216, divide it by 10 and what you have in there, and it says, all right, I found I need to deliver 321 BTUs per linear foot. Well, looking at their charts here, at the 140 degree supply, you got 320. At 150 degree supply, you got 380. So what's 1 BTU per linear foot between friends here? Okay, basically turn a light on, and it can be a night light to make up that 1 BTU difference. All right, so we're looking at 140 degrees that you can run out to this house. Now, one of the things that's important to consider when looking at this low temperature, especially with fin tube baseboard, One of the things is when you are designing and installing and setting up a system to do this with a customer, make sure you let them know beforehand, all right, that it's running at a lower temperature. And what's the difference between 140 degrees and 180 degrees? And I know someone's going to type it in there. And if you know me, please do it, but that's not the answer I'm looking for. What's the difference between 140 and 180? 40. There you go, Nick. Thank you. That's the one I was looking for. But Matt, yes, you said it feels different in the house, or it sounds different in the house also. When you start slamming 180 degrees out to fin tube baseboard, you hear the ticking and the growing of the fins and the copper pipe itself. When you start doing that lower temperature, it doesn't tick and move as much. So I had that issue happen in my in-laws' house. They had a 45-year-old boiler, and all the accoutrements all around it was still 45 years old. We pulled it all out. We put in modulating boiler, modulating circulators, modulating everything. And she called me. I called in the dead of winter when we had that first cold snap that year, and I asked her how the heat was doing, and she's like, "Oh yeah, I don't think it's working." Now, meanwhile, I just got on the road to be on a trip for about 4 days, and she tells me it's not working and I won't be home for the next 4 days. And I stop and ask right away, and I say, "All right, wait a second, Mom. All right, one, what's the thermostat set for?" And she said, "Well, it's set for 69 degrees. Now, what's the thermostat and what's the actual air temperature?" And she says, "Well, it's 69. And if you do that math, it says it's working, all right? She just didn't hear that noise anymore. So make sure you explain up front, because for a lot of people, the first thing that went through my mind was, oh my God, I got to get to the job site, or who can I call back on Long Island? Which contractor friend can I call up to come and take a look and see what's going on, since I wasn't going to be home for a few days. So to eliminate that trip, just make sure they know what's going on after the fact, that it's going to operate differently, not just their fuel consumption is going to be different.
Hey,
So,
Dave.
yes, sir.
Yeah, Jeff's got a good clarification. A lot of the literature will show up there sometimes shows that it's average water temperature, and you've said supply a couple times, and he's just questioning that. So Jeff House is wanting to know. Yep.
So I was doing a lot of digging myself and making sure and confirming as I did all this. And out of the Slant Fin charts, yes, Slant Fin was saying this is the supply temperature. It wasn't like blaring and glaring on a screen that I found over the last week and a half that I've been hunting, but I did find it in one spot. So Slant Fin is actually using this as a supply water temperature. Now, yes, pay attention to each manufacturer as we go through tonight. You'll see some others that use average water temperature. So, but just make sure you pay attention to those charts. So I was always under the assumption too, at the same time, that this was an average temperature too. And I used to use a lot of the times the 510 column, but doing some more research, right? And once you know, you can never unknow either, right? All right. So yes, so we're looking at supply here, but let's say we want to go lower. All right, and you want to get a lower temperature out of it, but you still only have, say, that 10 feet to work with. And there's a lot of different fin tube baseboard designs out there, and here's one of them called Heating Edge. And if you take a look at it, it's got 2 pipes in there and this large fin. Now, one thing to remember about fin tube baseboard, or actually just scrap that for a second, straight 3/4 inch copper pipe running 180 degrees through it will give you 60 BTUs per linear foot. You could heat a room with that by itself. You're just going to need a lot of it to wrap the room. So Slant Fin came along and they said, all right, let's go put these aluminum fins on it, and we increase the surface area. And by increasing the surface area and using that aluminum that bonded onto the copper pipe, the heat just gloms right out to the fins. And now you've got a much more surface area for that air to go across and grab those BTUs. So here, this one here by Heating Edge has a lot more fins, and it's got 2 pipe on there. So, so we could take a look at that too. So here, their charts, as you take a look at, is an average water temperature. So they will state it, all right, here, and they're talking about an average water temperature going out in the system itself. Now, the heating edge has a couple of different ways that you can connect up to it. You can do a straight through bottom supply with no return, like a regular fin tube. All right, you can do a bottom supply with a top return, which means when you get to the end of the loop, turn around and come back, and your supply and return is on the same side of the baseboard itself, as well as the top supply bottom return. Or if you really need to get a lot of BTUs out of it, you do two supplies in parallel. So when you start taking a look at some of these charts, all right, at that 170/180 supply, all right, if you were to take a look at two supplies in parallel, all right, at the 1 gallon a minute at 813 BTUs per linear foot, you're doing really good there. All right, so you get a lot of BTUs out of it. So, but maybe we're doing a new install, all right, maybe meaning we're taking out the baseboard itself, but we're still going to work with that 10-foot length that we have in there. So we're going to choose the top supply and bottom return as a number here. And that's just because of the way we're piping it in, right? So we wanted to, as we're doing this renovation, we want our supply and return on the same side. All right, and we find that we can get at the 1 gallon a minute flow rate, again, using the one again, you get to the 226 BTUs per foot. So let's take our 3216, divide that by 226, and we'll see. I'm sorry, I wasn't using the existing space again. I was all over the place. We were just designing what we had here. So we're going to get 14 feet of element at that 120-degree supply. All right, which would give us an average temperature of 110. 120 out, 100 back. 226 BTUs per linear foot. So you're probably going to fill that 15-foot wall instead of using the 10-foot wall, for example. So yes, if you were to increase the water temperature, but I was just showing that we can go a lot lower. All right, we don't have to see what we had before at that 140. Now we're looking at 120-degree supply.
Hey, we have a question from Gilbert Santiago,
Yes, sir.
who asked, if I have a house that uses 180-degree water temperature and you don't add extra baseboard, can I still use the modern, use a ModCon boiler efficiently? And I would say the answer there is yes, but you got to do the math. You may find that the house has, the heat load of the house has changed since it was first constructed. Maybe they've upgraded the windows, maybe they've weather stripped, maybe they've buttoned up the envelope, which is always a good thing to do. All of those things lower the heat load of the structure. And when you lower the heat load of the structure, you do have the ability to potential and keep the amount of heating element the same in every room. You do have the opportunity there to perhaps lower the water temperature that you need to heat that structure. So, and also a lot of times heat loads are way over calculated, right? We know that. And rooms are often way over radiated because, as Dave was saying, hey, every available inch of wall space, let's stick some baseboard on it. You just, at that point, you just got to do the math. Okay. And as Rich McGrath just said, just because a boiler makes 180 degrees doesn't mean you have to use it.
That's right. That's right. You know, and when that boiler was going in, the homeowners chose it for a reason. All right. And they want, and the biggest reason why they chose that boiler was for fuel efficiency. All right. So yes, we want to do the math and give them everything that they're expecting out of that boiler too at the same time. So lowering the temperature as much as we can and still satisfy the heat loss of the house is the most important thing that we can get out of it. If you need it to run at 180 degrees because of the way the heating elements are installed, then that's that. But make sure they also know at this point that they may not see that 97% efficient that we were talking about. All right, that warm and fuzzy brochure shows you in the beginning. So you want to make sure, well, you're going to see some savings. You're just not going to see as much as you can get if you're not doing that. So so now that becomes a decision on your part and also the homeowners, whether or not they wanted to go with that ModCon or go with the standard efficiency cast iron boiler, or lower the heat loss in other ways. You know, if they're looking, you know, that conversation of, I want that boiler because it's going to save me fuel. Well, make sure you can save fuel with that boiler to go in that house, and they didn't want to put any money into the upgrades. All right. If you're sitting at the kitchen table and you're going over the boiler with them and you see dust bunnies going across the floor, all right, and the air conditioning's not on or the heat's not on, all right, we've got leakage issues, all right, put money into the envelope of the house rather than into the boiler to try to save fuel. So, you know, sometimes we need to really listen to what the consumers are looking for when they ask us information. So we need to pry to them, ask them a question back when it does come to conversations like that.
Okay, let us know, Gilbert, if we answered your question. Nope, looks like we did. Okay, terrific. Carry on, Dave.
All righty. So with that being said, yep, we said we have 120-degree supply that we're going to send out for this type of application. So with that being said, check this out. I couldn't time this any better. I was quite surprised. It is trivia time at the half-hour mark, JB. I couldn't believe I got there.
That was really good. All right.
That was good, huh? Yes, I've been staring at this presentation for quite a few days. So yes, it is Takeo After Dark trivia time, everybody. So type those questions, those answers in there. And John is going to put your name into the spinny wheel, the random name generator. So this way we'll be giving off our grand prizes and t-shirts and stuff like that. So I was going to try and give the good old Cliff accent to this, and I decided against it. So so it's a well-known fact, you know, Cheers was on for 11 seasons. It ran from 82 to 93. So 11 years it was on TV. All right. And you can actually visit the actual Cheers bar today. It's in Beacon Hill, Massachusetts. All right. So the next question is, what was the bar's original name? All right,
in real life. In real life.
The real life bar in Beacon Hill, Massachusetts.
That's actually Boston. It's right on the Boston Common.
Okay. Or Beacon Hill is the street that it's on, I believe, right?
It's the neighborhood.
Neighborhood? Okay,
Yep.
I got you. So, yep, I figured you would know that a little bit more than I did. You know, the geography anyway. So, so anyways, excellent.
All right, they're pouring in fast and furious.
It sounds like you may have been nearby it at least at one point or two, John.
Oh, I've spent many an interesting evening there that we can have discussions about that really belong on Takeo After Dark. Oh, well, never mind. Carry on, Dave.
All right. So I guess it is time to get back to work, everybody. So, all right, so let's continue on. Before we get going anywhere, I do see a lot of the answers coming in right now. But also, were there any questions right before that? I thought I saw maybe one or two. Rick, I don't know if you happen to see any questions come in, or were we all good there?
No, we did have a couple. Let me let's throw one out at you.
Bunch of stuff loaded.
Yeah, ModCon's still okay at minus 10 degrees, may need 180-degree water, whereas at 55 degrees, you may only need 140-degree water. So yeah, you will stick at a ModCon modulating, even if you are doing 180 degrees under design conditions, absolutely. Let's see. Isn't the boiler efficiency based on the manufacturer's chosen specific temperature?
It's based on AFUE standards when they get the boiler tested. So there's a specific return temperature that they use in the test. And I can't tell you what that is. To get the numbers as high as they are, it's probably lower than 130. So, you know, so everybody can be tested on the same basis. You've got a standard that they have to meet, and so they can't treat anybody any different. They say, okay, if we run your boiler and we bring this temperature back, what kind of, you know, combustion efficiency, overall efficiency, et cetera, and then they test out. They either get the 95, the 96, you know, numbers that we're talking about, or they don't.
And George also brings up a good point here. I just noticed, you know, the ModCon's still good at minus 10, and yes, you need that 180 degrees. But when it gets warmer outside, let the boiler modulate. What I mean by that is also put the outdoor sensor on, put it outside, all right, and program it. So I learned this statistic not too long ago, and I was floored that 60%, 60% of modulating condensing boilers that are installed do not have the outdoor sensor hooked up. So I was floored when I heard that. So you're putting them in, put that sensor in there, but then also program it too. So even if you do need the 180, make sure you understand the bottom end of it too. All right, on how low it can go at the same time. So there are bottom ends and whatnot to set up. So go through the programming and understand all the settings that you have there. All righty. Oh, Omer had a question in here. He was looking at with the rising costs of fuel, oil, propane, will high efficiency become the only option? I don't hear any of that right now, but also, I'm not working with a boiler manufacturer and paying attention to that scuttlebutt. We hear the scuttlebutt with circulators and trying to save electrical savings throughout North America right now. But as for the boiler world, I don't know if they will be, so to speak, mandated out of existence. I don't think so. I don't think that would be the case.
But there is also that, but that brings us to a very interesting question for next week. Let's hang on to that one.
That's right. That's right. So, all righty. So let's continue on. Now, we're paying attention to a lot of the existing heat that's in our houses, right? And if we happen to see that we have cast iron radiators and baseboard out there, all right, especially when it comes to that radiator that's installed in a home. And there's a lot of people that love them. They've been installed for many, many years in their home. All right, obviously, you take a look at an old radiator like this, and then you look right above it, and it's been all brand new windows, new envelope, new insulation. So this thing is going to be way, 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 way oversized, all right, for it. So let's also pay attention on how can we work with these rather than rip them out. Rather than rip these things out, because homeowners do love them and the amount of heat that they give out, and they hate them at the same time because of the amount of heat that they give out. So my wife had an apartment before she was my wife in Brooklyn, and she had this big old cast iron radiation in there, and in the middle of the winter, her window was open 50% just so it would cool down in there. So so what you need to know out of your radiator there is the effective direct radiation, your EDR numbers out of it. And this one here, well, my example that I'm using today, maybe not this one here, is going to give us an EDR of 24.5 square feet is our EDR. So that's information that you want to get. Now, if you want to find out how to get that, we've done this at Takeaway After Dark, and it's our factory class week 2. So if you want to go back and review that, I believe I've also included in the handouts, and one of those handouts will also go through how to find the EDR of a radiator itself. So you can dig that out there too. So when you have that 24.5 square foot of radiation out of it, then we go and take a look at some charts. And these charts happen to be from Stelrad that I had grabbed a couple of years ago. And what you're looking at here is your heat emission rates, BTUs per square foot, and what water temperature you need to supply out there. So we take a look at 3216 is our heat loss. We have 24.5 square foot of radiation, and that tells us we need to give off 131 BTUs per square foot here. All right, which means when we start taking a look at the chart, so we're just doing a little backwards engineering here at 130. Let's go grab the 130 row. And that says we can heat this room with 160 degrees. All right. So, so just again, pay attention to the number so you can lower that water temperature as much as you can and whatnot. So, so that's what we're looking at with our cast iron radiation. Now we come along to cast iron baseboard, and again, lots of people have them, lots of people love them. They love them because they give off a lot of heat, and they hate them because they give off a lot of heat. All right. And I just recently came across a new old stock over at my buddy's house around the corner. He's got cast iron radiation throughout the whole house. And the previous owner was a contractor, and they had about 30 feet of baseboard shoved underneath the stairs that was still there in the house unused. So he was doing some renovations, and he was doing some additions on the place. So he was able to continue on with the cast iron baseboard. He was quite happy with that. So again, we need to find out the BTU per linear foot outputs of it. So here, this is from Burnham and their base ray baseboard. All right. And, you pulled up here, and it's got two different flow rates, and it's showing you in 2,500 pounds per hour. All right. Which then they converted over to 4 gallons and 1 gallon a minute. All right. So you just got to make sure you're looking at the right chart. All right. And it says if you know it to be 4 gallons a minute, then great, use the top row. If not, you use the bottom row. So we're going to be working off this bottom row here for your cast iron baseboard for the base ray here. So again, we've got, say, 10 feet installed in the room, 3216 divided by 10, 321 BTUs per hour. We need 150 degrees. Doesn't have to be the 180 that was originally operating at. So 150 degrees for your cast iron baseboard to work with it. All right, and not last but not least, we got a couple more to go still. Start taking a look at panel rads, and there is some growth happening with panel rads. I know John and I have talked about panel rads quite a bit and discussing it as a European method and style of heating. All right, but it is also growing here in the States. It's got a totally different look to it, and it does have different types of radiation. You do have just that straight radiant energy coming off of them. And then some of the panels will also have some fins in the back to help with that heat transfer. So you've got a lot of different designs out there. And you've even got panel rads that are based like a baseboard to go the length of the wall, or you go up the wall with them. So are there any, before I get any further here, JB, are there any questions up to this point? How are we doing?
Yeah, I do have one from Colby, but not worried about reusing existing cast iron radiators and steel pipe with a new high efficiency boiler, scaling the existing system, plugging up that heat exchanger. Are we worried about that? No, because of was it 2 weeks ago? 2 weeks ago, we had a full hour on boiler water treatment and the importance of cleaning and treating the water within systems. So yeah, you should be worried about that, Colby, but there are ways to work with that and to take care of that and address it long before it becomes a problem. Patrick S. from Mondale and Associates gave us a great presentation on boiler water treatment and the importance of treating that water for just the reason you bring up. So yeah, absolutely got to be taken care of.
Right. So you can work with your water chemistry for one, and you can do two, go mechanical means. All right. And putting in magnetic dirt separators can also pull stuff out. So you can do both. And and if you're working with a really old system like that, like I showed you before, then yeah, I would consider doing both as you do major surgery to the system. And putting in some cleaners before you take out the old boiler, and then put some cleaners back in again when you put the new boiler in and the new piping, and then put the, so yeah, there was a whole bunch of stuff that Patrick had talked about, and also putting in some magnetic dirt mechanical means to get that out there.
There's another one here asking about dual fuel, and somebody's questioning whether or not you would get your warranty or not. Basically says, I hear when they utilize dual fuel condensing boilers with gas being primary fuel, manufacturers will accept the warranty. However, when using it with oil, they will not honor the warranty. What's the reason behind that? That typically has to do with the way that the products of combustion condense. When you use an oil, that product, it's always fairly nasty and acidic, but it's even more nasty and acidic when oil condenses. When the products of combustion out of an oil burner, the products are different, and they're more acidic, they're more caustic, and that might be the reason. I'm not, that's what you want to look towards though. So that's why there's not that much condensing oil equipment on the market. There are some, but it's rare.
Excellent. Thank you everybody for those questions. Greatly appreciate it. Keep them on coming in there. So let's take a look at panel baseboard for a second. And the company I'm looking at here at the moment is going to be Runtal. All right. So again, we're going to stick with that 3,216 BTUs per hour. And Runtal has a baseboard style, as you see here, 2 rows high, 3 rows high, or 4 rows high. And you can see here at 180 degrees what their output's going to be. And now this is again a supply water temperature that you're looking at. All right, and and also the single. All right, they do also have the single here too with Runtal. So these are steel panel radiators, and here you can see the backside of it with the fins themselves to help you get some more BTUs per linear foot. So if you're gonna get kind of close to say a regular fin tube baseboard from Slant Fin, like we were talking about, at 580 BTUs per linear foot, you know, your 2-row here is going to get you a little bit more. The 1414 or VLX or I guess they call it UF2. Maybe it's got a couple of, maybe this is without fins and that's with fins. I'm not sure. But I do know we have a couple of Runtal people online with us tonight too. So if you've got any questions, please ask away, and hopefully we can have some of those guys answer those questions at the same time. So if it was at the 180 degrees, all right, divided by 6.2, and we get 5.2 feet needed, all right? So this is if you are, say, working on designs and working at 180 degrees. Now, there are also some charts that they have put out there to give you at lower temperatures in what you're going to achieve for BTUs per linear foot. All right, and if we look at it coming over to 3216, let's say we had that 10-foot wall installed again. All right, as we have that 10-footer, we're going to use that number over and over again today. We're back again at 321 BTUs per foot. And let's say we come scrolling along and we get close to the 320. Let's look at the 349. Now here again, these charts, they're looking at average water temperature, whereas before it was 180 degree as a supply temperature. So here's your average water temperature, which means we're going to send out 150 to get close to my 320. So again, and remember that a lot of these numbers that I'm talking about is your design max temperature on a design day when it hits the coldest temperature of the year itself, which is going to be about 2 to 2.5% of the winter. All right, the rest of the winter, it's going to be warmer than that temperature. So if you set up that curve properly, 150 would be the max. 20-degree delta, 130 coming back. The boiler, yes, is starting to condense a little bit, but that's only on that design day. So therefore, the rest of the winter, it should be condensing more. So, and yes, as Rich just mentioned here, you know, take a look at some of the other models, and you start getting up there in the 4 rows for your baseboard, and now we're back up there, 140 degree average water temperature gets us 544 BTUs per linear foot. But as we start dropping that temperature, here we go, 120 as the supply going out on a design day. If you went to the 4 rows high, which will still match up to our design that we were looking for.
And gosh, Dave, why would we want to get the water temperature down to 120 degrees?
Because it's condensing as it's making it.
Yeah. And I'm wondering if there's other things that we might, reasons we might want to get that water temperature down that low. Or and for those of you who slept through high school English, this is a literary technique known as foreshadowing. Okay, just saying.
That's right.
There's something from George here talking about overshoot, basically is what he's getting to. He's just saying there's one thing he doesn't like about cast iron radiators, and that's because of the mass, etc. I'm paraphrasing here, but George, normally that's because the water temperature that's being used is higher than it needs to be. So what an opportunity to reset that boiler fluid temperature and not have as bad an overshoot. We deal with the same thing with radiant floor. So anyway, just start dialing in the actual reset curve appropriately, and you'll have less of that overshoot.
Exactly. And that was my statement that I was saying before about your cast iron, is that, people love them and also people hate them, because when they hate them because they give off so much heat. All right. And yes, you get that flywheel effect in there. So by doing this also is not just about making the boiler condense. All right. But we didn't need it to do that much heat output. So therefore, one thing about a heating system that we want to strive for is to make sure the homeowners don't even know it's on. They shouldn't know it's off. They shouldn't know it's on. It should be silent. It should be quiet. It should just be. That's really our goal, all right? What your thermostats kind of end up being is almost like a high limit. If you can dial everything in just right, your thermostat kind of acts as a high limit. So when you see this number, 3,216 BTUs per hour, how could you be comfortable? Can you deliver that slowly over 60 minutes, or do you want to deliver that in 5? Right? You dump 3,216 BTUs, you know, into this room in 5 minutes, or do you want to do it slowly over an hour? You do it slowly over an hour, and it's just nice and gentle in the space, and you don't know the heat's on, you don't know the heat's off. Are we using any more fuel? Absolutely not. The heat loss is the heat loss. The room can only take so many BTUs based upon the BTUs that leave the room. That's it. So that's the goal here. So if you can lower that water temperature and get closer to the actual heat loss of the room itself by the heat delivery to match back in there, it starts to feel a lot more comfortable. A lot more comfortable. We start thinking about forced air. All right. Does forced air do any of this? If it says I need 3,200 BTUs, what's it going to do? It dumps in 6. All right. But it does it for about a minute and a half and you're done. All right. And okay, now it backs off. So you always have that flywheel effect going on in the room itself, whereas by lowering the water temperature or adding more mass or more element to it, we can try to get more even temperatures in the space itself.
And gosh, what would happen if you put a Delta T pump on that thing too? Sorry, that was my outside voice.
I know, right? Sorry about that. Yes. All right. And so coming out of the panel baseboard side of things, now we start looking at the radiators like we had before. And yes, there's charts on it, right? So you start taking a look at the charts. And let's say in this room here, you've got a nice 4-footer installed on the wall. All right. So we look at the 4949 here, you know, going way up there and 4 feet wide that was installed into the space itself. So again, let's take a look at the math. Now this one happens to be a 7-tube high panel radiator. So 3,216, divide that by 4 foot, which means I only need 804 BTUs per linear feet. So we come and take a look at the chart, and we're going to have to extrapolate between the two of them if you're really looking at it, because we're stuck. You know, we already have the 7-row installed. All right. And we take a look at 804. Well, that kind of falls in between 946 and 785. So let's just assume we're going to set this thing up again, showing this chart showing us average water temperature. So 135 average, let's make it a 145 approximate supply going out to the system itself. All right, so by using these panel rads installed in there. All righty. Now, what most people consider some of the lowest water temperature heat emitters out there is looking at radiant floor.
Hey,
So
Dave, before you, can I interrupt you real quick? We had a bunch of questions come up specifically about Runtle, and I know we have Jonathan Weiberg from Runtle on the call. And Jonathan, if you could just text me, shoot me a note or a question, and we'll see if we get you online after we're done with the main part of the presentation, and maybe you'd like to answer some of those questions directly. If you're willing, let me know. If not, just feed me the answers and I'll deliver them. So either way. But I just wanted to let you know and let everybody else know we do have a guy from Runtle on the line who will hopefully help us out with some of these questions.
Excellent.
Get it straight from the source.
That's awesome. That's awesome. Yeah, I haven't personally worked with Runtle in unfortunately about 25 years, 20 years or so. So it's a lot of the stuff is gone out of my head. I don't remember it anymore.
We do have a bunch of it in our factory in the training room and in other rooms. It's pretty tough stuff, and boy does it put out some nice heat.
Yes, yep. So, but meaning designing and installing around it, that I don't remember any longer. So, yeah, I don't know what I've been doing for the last 25 years. Oh, wait a minute, radiant floor heating and takeout. Yes. All right, so let's talk about some radiant floors here real fast. And one of the things that we really need to know about radiant floor heat when, again, heat loss is done. All right. Whenever we talk about radiant floor, we always want to talk about the BTUs per square foot. How many BTUs per 12-inch square can I get out of that to heat the room? That's what we're looking for, right? So how much can you get out of 1 square foot of floor? The math is easy here. All right, so our room being 3,216 BTUs per hour divided by the square footage of the room, and we get 150 square feet, and therefore we're at 21 BTUs per hour per square foot. All right, so whenever you're talking about radiant floors, it always comes down to that square foot because your floor is the radiator. One thing to remember, I'm going to go back to this, that pipe is not heating the space. All right, what you're looking here is not heating the space, it's the entire floor assembly is heating the space itself. All right, so we're not going to get involved in different pipe sizes and lengths of pipe and stuff like that today. What we are talking about is BTUs per square foot of floor mass that's going to heat the room. So typically, as we start looking at our different heat emitters, the more mass you have, the lower the temperature can be. Okay, so here you've got the biggest mass out there, all right, the entire floor, or wall or ceiling. So right now I keep on calling it floors, but it can be radiant panel heating anywhere that you're looking at in the space itself. So I pulled out some charts from Uponor here, and I did not include these Uponor charts in the download section only because they had this as an entire book of 320 pages. So it was just a little bit large of a file. So take a look at their CDAM, their Complete Design Assistance Manual, and towards the back of the book, you'll find these charts in here. So this chart happens to show us a concrete slab, that's a 4-inch slab, and we've had this tubing installed at 9 inches on center. So a couple things that we need to know here before we figure out what water temperature is one, the heat loss, which we figured out already at 21 BTUs per square foot, as you can see here on the left-hand side, all right? And then what we also need to know is the floor covering R value, what kind of finished floors are thrown on top of there. And there's also charts of that in the CDAM itself. You find that and you follow the lines, and where the two lines intersect will tell you the water temperature. So 21 BTUs per linear foot, per square foot. All right, and this one is, let's say I chose a 1.2 R value for a finished floor, and we see a concrete slab at 9 inches on center with a 10-degree differential is going to give us 110 degrees. Now, radiant floors, we typically like to do a 10-degree differential, meaning going out, so it's going to go out at 110 and come back at 100 degrees. If you're looking at a 20-degree differential, we're looking at 115 and 105. At 115 degree as your supply water temperature with a 20-degree differential. So most residential systems we like to set up on a 10-degree differential. If you go commercial, you can easily go to that 20 or 25-degree differential. So that's your slab with PEX installed at 9 inches on center. Now, let's say I want to get that water temperature down lower. What do? Couple of things, right? You could change the R value on top, all right? Still keep the same 21 BTUs per linear foot, but now if we went to, say, tile floors that had a 0.5 R value, you bring that back over here to where the two meet, and we're looking at about a 93-degree water temperature being sent out to it. All right, now if you were to change the spacing of the tubing, so the changing of the spacing of the tubing itself will also change your water temperature. So let me show you an 1.5-inch poured floored underlayment. So now we're looking at a thin slab, which means there's a basement below or a first floor below the room. So now we're going to have tubing installed at 12 inches on center. So we do the same thing, all right, where we're looking at our 21 BTUs per square foot, the R value of 1.2, and our water temperature here is going to be slightly over 130 degrees. So by changing the spacing, you can also change your water temperature design. You can drop that down. So closer spacings brings the supply water temperature down. Pipe size has nothing to do with that. Pipe size has everything to do with loop length and head loss that you have going on there, but not going to control how much heat the space gets. Now, if you don't want to be working with a concrete high mass systems like here, and we're looking at from below the floor, now this one, your spacing is set by your joists. And since we're looking at most homes looking at a 16-inch on center joist cavity. All right, we're going to have 8 inches on center for our tubing, doing a loop in each bay for our joist heating with heat emission plates, thick plates. All right, where you put the plate up first and you snap the pipe in afterwards. All right, so we come across again with our 21 BTUs per square foot. Come across to your R value. Now, these charts with Uponor, you got to pay attention to each manufacturer here. This chart already has the R value of a 3/4 inch plywood floor installed. All right, thrown into that R value. So if you're just doing, say, a wood on top of that, like a finished wood floor, now you just have to worry about that layer, because every house that has a suspended, application is going to have a plywood deck. It has to. All right, so it already has that 3/4 inch plywood floor R value thrown in there. So you come down to where the two of them meet, and from below the floor with joist heating and joist track, we're looking at 110 degree supply with say a hardwood floor on top. And if you decided to get rid of the plates, here's your joist heating, no plates. Again, 8 inches on center. All right, 21 BTUs per square foot. All right, R value of 0.7, and now we get about 155 degree supply water temperature. All right, so again, adding mass, right? That's what the plates were doing. That's what the concrete does. It extracts the heat out of the pipe itself. All right, so there's your difference. Could I heat this house with 155? Sure, again, design day. All right, so that's where my boiler is going to operate at the highest point on the design day, on the design numbers. All right, then hopefully it modulates down from there. Excellent, excellent, excellent. All right, how we doing out there, everybody? How we doing, JB?
Got some good questions. A couple came up about why design radiant to a 10-degree delta T. It's kind of traditional, but the real reason is if you keep the delta T's nice and tight from the beginning of the circuit to the end of the circuit, you wind up with more consistent floor surface temperatures, which is really what we're looking for with a radiant floor heating system. In a 4-inch slab, can you do 20 and it'll be okay? Yeah, in most cases you can. But as the mass goes down, that 10 degrees is a lot more important, especially if you're in between the floor joists and you can't necessarily get the hottest water to the outside wall. You're kind of at the mercy of the floor joist layout. So that's why you generally design to a 10.
We can also change our layout pattern and still use a wide delta T and still get a nice even floor surface temperature profile. But most people don't want to do that, or they don't remember to do it ahead of time.
Right. If you do the spiral technique versus the
Yep.
serpentine, yeah.
Yep.
Right. So it's like even in my own house, and also when you're doing your designs, and it's mostly, for example, in my house, I have a lot of my underfloor designed to about a 15-degree delta, and I did that just so I had the loop lengths to work with, because if I kept it to a 10-degree delta, then I would have had to add a couple of extra loops in there, a few extra connections on the manifold. And this house was a pain in the ass to install some radiant floors in because of the steel beams that I had. So to try to get from one side of the steel beam to the other, so some of the rooms I designed out to a 15-degree delta, kept my head loss down low so I can stick to standard size circulators rather than going to something exotic with a higher head out of it. So when we do, say, some of the sandwich style systems with the real small 5/16 pipe that you have out there, those are already designing themselves on a 20-degree delta because of the small diameter pipe. If you were to try to make that on a 10-degree delta, you could do it, but your loop lengths are going to be about 120 foot each. All right, so you're going to have manifolds the length of the house.
Yeah, either that or we'd have to airlift a pump to the job.
Right, yeah.
Which we could do. We make them.
Yeah, we got those. Yeah, we got them. Yeah, definitely. Excellent. Any other questions?
Let's see. We got another one about Runtal panels. And to finish up, Jonathan Weiberg's agreed to come on with us. So why don't you finish up, Dave, and we'll do the trivia, and then we'll get Jonathan on and address all these great, these terrific Runtal specific questions.
Excellent. Well, that was pretty much, I am done. So talking about lowering that water temperature, right? Make sure we set up that outdoor reset curve. You put that boiler in there or whatever you're doing, whether it's going to be the boiler itself, and understand each boiler may be a little bit different on how it sets up the outdoor temperature curve on there, but make sure you follow the free manual.
The free one.
Yes, and as I said before, make sure you install that outdoor sensor. All right, install that outdoor sensor, and and make sure it goes outside on the north side of the building, away from any venting, away from anything that is make it warmer than it really is. That's the important part too. I've been to a few job sites recently where I found the sensor. It was hooked up to the boiler, and it was in the boiler room. It needs to go outside and reading ambient air temperature. All right, so therefore we can modulate. All right, modulate the world. All right, because we design everything to heat on the coldest day of the year, and we only need that about 2% of the winter. The rest of the entire winter, our entire mechanical room is way oversized. So if we can start modulating everything and letting it do what it's supposed to do, that's when we're going to really start achieving a lot more comfort and the efficiency that homeowners are looking for. So the lower the water temperature, the better the system's going to operate, all right, and get you to that 96, 97% efficiency out there. Okay.
What if we wanted to go to greater than 100% efficiency, Dave? What could we do there?
Oh, that's when the boiler gets a job and starts paying us to heat the house.
Or could we be looking at another form of generating warmish, not necessarily hot water?
That's right. That's right.
Yeah.
So yes, Eileen nailed it almost.
Oh yeah, yeah, almost. Eileen. Yeah, well, I mean, I think it's
Well,
time to.
it is almost. Yeah, it is. Yes, instead of using fuel, Eileen. Yes, we're looking at some heat pumps. And Sean, yes, correct.
Let's flip the cards here, okay? Like we might as well just go ahead and do that. This whole thing was kind of a warm up for next week when we want to talk to you a little bit about a new product that Taco's coming out with called the System M, and it is an air to water heat pump. And what we're going to be sharing with you next week, and we're going to be talking about a lot of different things, but part of the presentation will be on this System M heat pump. It's not going to be a full on training on the thing because we're not particularly ready to that, but we will be giving you a look at it and give you an idea of what some of the benefits of that thing might be. Primarily is that it just works awesome in that 110, 120, maybe approaching 130 degree range for heating, but it also can handle cooling loads, and it can also create domestic hot water for you. So it's a multifunction unit, and it uses no fossil fuels. There is electric resistance backup heat built into it that'll automatically switch on when it is needed. But that is pretty cool stuff, and it's what we're looking at. And I spent a good part of the day online looking up all the information about beneficial electrification. Not just electrification, but beneficial electrification, where, do they burn fossil fuels to create the electricity? Yeah, but in terms of delivering it and in terms of integrating more and more renewables, we start to do the things for, carbon footprints and harmful emissions to reduce those things, greenhouse gases, reduce those things to be carbon neutral, but also to be able to efficiently and effectively create heating, cooling, and domestic hot water in a normal residential structure. And we're going to talk a little bit about that next week. And wicked cool stuff, really, really cool stuff. And we're very, very excited about being able to bring this to market. It's going to be, might be a game changer for us.
Yeah, if you've been to the AHR show over the last 4 years, we've been showcasing it there. We've been showing it there for the last, the past 3 years. It was a concept car for us, and so we've been working on it, and we've been working on it with a manufacturer based in Germany that does the heat pump. So it's not like we are designing heat pumps now. We're letting the heat pump guys design heat pumps. All right, but we've kind of got some unique things partnered up with Dimplex over in Germany in working with these heat pumps. So we've got some really cool stuff that we want to show you along with their heat pump technology and what we're doing on the other side of it. So it's going to be some cool stuff. Like John was saying, it's coming this year. All right, so we are still developing and putting together a lot of the training program itself. If you are coming to learn all about heat pumps and Taco After Dark next week, that's not the class. All right.
Yeah.
We'll teach you some stuff. Yes.
Yeah, you're going to know what the thing can do and get a look at it and understand some of the capabilities. We're looking at June for this thing to actually kind of be ready to hit the market. For those folks that are interested, let us know, and we'll try to help you along with that.
All righty. With that being said, it is Takeo After Dark trivia time. With
Boy,
Mr.
did a lot of people get this question right. I was typing away like you were the other day.
Are you all done? Are you ready to give away?
I'm ready to rock. You do you give the answer, and we'll give out the goodies.
Yes, like I said, Cheers ran for 11 years, and the Cheers bar today is in Boston, Massachusetts, in Beacon Hill area. All right, what was the bar's original name? And I saw a lot of people up to writing that answer in there properly. And yes, it was the Bull and Finch Pub. And the name is gone. All right, back in 2002. So that picture that I showed you before of the Cheers sign, that's what's hanging there today. Now, that's not where the show was filmed, obviously. And actually, the Bull and Finch Pub, when you look on the inside back then, it didn't look like the Cheers show at all. All right. Today, it kind of does. So they kind of emulated the inside to what the TV show was. But the Bull and Finch originally was not looked like the Cheers TV show itself. So they made it look like that later on, but they did like the way the neighborhood feel was of everybody hanging out in there and going down the stairs into the place. That was still original to it. So
yeah, those all the outdoor shots were filmed right on location there in Boston.
Right.
And you would walk downstairs into it, and sometimes you'd stumble upstairs. That's my own experience anyway, but we won't get into that.
So excellent. And I'll bring the wheel up. I got one last slide, JB. All right. And Mr. Bruce Campbell is telling us next week is our winter season finale. All right. And our low temperature heat sources and controls. And so JB already talked about it. Yes, we will be talking about the System M components as well as other things to help you get that low temperature that we're looking for. So we'll be talking about eye valves for one. All right, if you're not sure what an eye valve is, tune in for that, and also learn about the System M system that we're going to be pulling up there too. So come and hang out with Bruce Campbell and the rest of us at Takeo After Dark and Mechanical Hub. It's sure to be a hoot. So,
all right, can I take the wheel?
Said, I am done. Let me turn around, and it looks like you already took control.
That's the kind of guy I am. All right, can you see my screen?
Yes.
Yes, I can.
All right, there we go. All right, well, we're gonna spin to see all these guys here got that question right. So I was typing like crazy. Let's see what we got for our grand prize, which is all the cool stuff that Dave has in his basement. And the winner is
Dana
Larson. All right, congratulations, Dana.
Alaska boy.
All of your information. So terrific. Congratulations, Dana. And Dave, we're talking about the T-shirt, the Bluetooth speaker, what else? Coffee mug,
Bluetooth speaker, a coffee mug. I did find a little stash of some camo hats from Takeo, and the travel mug. Those I love having those travel mugs because I always end up leaving them on some water heater on every job site. So so I got and other accessories that I got thrown down there. So excellent. Awesome, Dana. Good job. If you registered with your address and the shirt size, then I will make sure I get that out to you as soon as I can. So I'm hoping by the end of the week, all the past stuff, I do have a couple of holdouts still, meaning a last few shirts and stuff to give away. But I did send a lot out on Friday. So for those of you that have been around and you've won some stuff and you didn't get it yet, Friday, everything just went out. So they will be coming. And JB, any T-shirts we want to give away?
I'd say let's give away 4 T-shirts. What do you think?
All right.
All right, 4 winners for 4 T-shirts. First winner for the first T-shirt will be Larry DiGiovanni.
Larry.
Bene, very good. Congratulations. Very good, Larry. Okay, next T-shirt's gonna go to tick. Gene Bennett. Congratulations, Gene. Another Takeo T-shirt winner for the Takeo After Dark T-shirt. All right, so we're halfway there. 2 more, right?
2 more. There you go. Yes. while we're spinning, type in those questions. We're not going to let them go away. We'll stay on as long as you want to tonight.
Brian Nickel, congratulations, Brian. All right. So one more, last T-shirt for tonight.
Alan
Franklin. All right. Congratulations, Alan. Excellent. All righty. Very good. Very good. Okay, we got a bunch of questions here, and what I'd like to do, let's see if I can find Jonathan here. Jonathan, are you still with us? There you are. I'm going to turn on your microphone. I just turned on your microphone, Jonathan. How are you? If you can hear us.
I'm doing good, John. How's it going?
Very good. Very good. Now you are with Runtle. What is your position with Runtle?
Today?
Yeah, today.
I'm the national sales manager for the residential division.
So you're an important dude.
Well, I'm a dude.
Oh, go ahead. Well, we had a bunch of questions regarding Runtle. One of them was, the first one was just pretty basic, standard pipe connections, or is it the Euro style? Now you make these just down the highway from me in what's your city?
Ward Hill, Haverhill, Massachusetts.
Haverhill, there we go. Haverhill, Massachusetts, Ward Hill. I'm going to presume that what you make in Haverhill is going to have standard pipe connections, correct?
Correct. National pipe thread.
National pipe thread. So regular old pipe connection. You don't need the hemp and that straight European thread stuff.
Correct.
All
I
right.
do not.
Well, the hemp's optional.
Well, not different hemp. Different hemp.
There's a lot more hemp these days.
Gotta say it, man. It's optional.
Different hemp. A couple of questions did come up, Jonathan, about sturdiness. Are they? I mean, I've installed them. I know they're real sturdy. What can you say about the sturdiness of the Runtle product?
Well, being a steel panel radiator, it's all welded steel. It's a heavy gauge mild steel, so it is as sturdy, probably 80 to 90% as dense and sturdy as cast iron baseboard. It's a carbon steel radiator, so it's all welded steel. It's resistance welded and hand welded together, so it's very sturdy. Actually, we do a lot of work in public housing. We do a lot of work in dormitories for colleges because of its durability and sturdiness. It's virtually bulletproof. Well, not bulletproof, but it can withstand a college. It can withstand a little red wagon.
There you go. And you really have to take a sledgehammer to it to cause it any serious damage. I've found. Not that I've done that. I just been installing them. They're very, very sturdy. In terms of dings and things, I did notice, dings and things you do offer like touch-up paint and things like that for different colors. Yeah. Okay, terrific. Now, guys, any other questions that you guys have regarding the specifics around Runtle? Now, these things are rated, Jonathan, to really low water temperatures. How low can you go in terms of water temperatures on some of your radiators?
With our outputs, we go down to 120. You can probably go down a little bit further than that. The product was designed with the Swiss product was designed originally for low water temperature, low flow, low energy consumption. That was the mindset behind that 75 years ago when they were designed. Here in the States, we've been doing it because of its durability and its attractiveness. But now with low temp systems like you're working on and talking about tonight, it's become more of an option. So you can go down as low as 120, but I've seen people with other systems with solar or what have you go down lower than that. I don't know what the output is at that point.
And at that point, the basic rule follows: if the lower the water temperature, basically you just turn it into a bigger radiator, right?
Yep.
You need a bigger radiator to deliver the BTUs necessary. What else can you tell us about Runtle? How long have you been in business here in the U.S.?
Runtle was started, it's funny, you're in Exeter, I'm in Brentwood. Runtle was started in Exeter as an import company 40 years ago. We started manufacturing in Haverhill, Massachusetts 36 years ago. I've been with them since then. And again, it was born from the Swiss technology of low flow, low water temperature. Originally, it was brought over here for nice looking radiators. But as energy prices have gone up, energy consumption has become more conscious on people's minds. It's become more of a product geared towards efficiency and comfort. As you guys know, for years, the radiant floor system was sold on design comfort and efficiency. Panel radiators are very, very similar. So everything that we make in Haverhill, Massachusetts services all of North America and Canada. And we we do most of the panel radiators that you see anywhere in North America, towel warmers to baseboard to wall panel radiators. We employ about 75 people in the factory and about 30 people in the offices. And we've been in the same facility in Haverhill for 36, 37 years now. Good factory.
Very good. Very good. Let's come down and visit someday. I'd love to see you make
Please do. Please do.
if you have visitors, if you're not allowing visitors in the factory, I'd love to check that out and see some radiators.
As a matter of fact, we just started doing chapter events with the PHCCs and the NKBA. We did one last night. We do factory tours. We have a full showroom. And we like to see people come and look at the radiators. We did an episode of how it's made. So you're always welcome. If you're ever in the area, if you're ever in Haverhill and you want to see radiators, come on by. I'd love to see you.
Excellent.
Terrific.
Excellent. Now, there were a few comments that came in. So Rich McGrath said they are friggin' bulletproof. I know you didn't want to say that before, but he's saying it. So
yeah, for sure.
And Alan was saying some of the panels are great in powder rooms and really nice besides sliding glass doors by going to a vertical install with them. So yeah, you know, right when you got that heat load right there. Because as far as I know, you haven't made runtles to slide on the door yet, right?
Not yet. We got into magic water first.
Or how about hinge? Do you have them hinged so they go right in front of the door?
Some of the towel radiators, maybe.
There you go. There you go.
There we go. That's right. And Bob was making a comment too. It's like there's so many different ways to pipe them in. It works well and adapts well to remodels. So that, which is nice about them too. So you've got a lot of retrofit applications too. That's awesome.
Yeah, we standardized a lot of the product as well. The lead times aren't unbelievable as they used to be. Now with the supply chain issues, we do have issues with that like everybody else, but it's not nuts.
And I do know we do have a bunch of it in our factory and especially in our training room. So for those of you that are waiting for the training schedule to come out, hopefully it comes out soon enough at the factory and you'll get to see some. And what we got from you guys was some custom stuff because we had the outside room that our training room is curved. So we actually have some, I believe they're 20 footers, 3 sections of 20 footers that are curved. Right there on supports to the floor themselves, so they are nice looking too. Yeah,
that must look nice. Yeah, we do a lot of curved things. That I remember that project.
Very cool. Well, okay, can you stay on the line with us for a little bit, Jonathan? Because we got a lot of questions here, and guys, this is open forum time now. Any question you have regarding tonight's material, next week's material, or anything we've ever presented over the last 2 years, now's a pretty good time to bring that up. One question I want to get to regarding air-to-water heat pumps, Scott Jones asked, how efficient are they compared to natural gas? Well, a lot of it depends on how well they're installed. They've got to be sized properly. They got to be installed properly. But next week we're going to get familiar with a term called COP. All right, which is a way of expressing the efficiency of a heat pump. And the higher the number, the better. And we're talking about COPs of 3, 3.5, 4. If a unit has a COP of 4, all right, that means for every dollar you put in of electricity, you get $4 worth of energy back. It's almost as though, you know, the heat pump is a bookie, a really bad bookie, and it always loses, right? So you put in $1, you get $4 worth of energy back. Now, as it gets colder out, that COP will tend to drop because now we're starting to really tax it. But with inverter technology, the heat pump that we're going to be talking about is good to what, Dave? About 4 degrees above 0 Fahrenheit?
You're taxing me now. Yeah, I'm brain's full of other stuff right now. Yeah.
Yeah, and then we're talking about 44,000 BTUs for the unit we're talking about now, and it can still extract heat out of the air through the refrigeration cycle at about 4 degrees below 0. After that, it's almost exclusively on electric resistance backup. But we'll be able to give you a little bit more information on that, a little bit more accurate information on that next week.
There was a question about modulating the temperature. Somebody's got, you know, outdoor reset.
Sorry.
What's that?
Minus 8 degrees.
Minus 8 degrees. There we go. Minus 8 degrees.
So they're saying they're worried about the thing. And again, a lot of people there, I shouldn't say a lot. There's people out there saying you shouldn't modulate the temperature of the boiler and vary the speed of the pump at the same time. But that's we've proven that that's inaccurate. Somebody's blowing smoke it works pretty good. So
Yeah.
we don't, a Delta T pump, if we're talking Delta T, and I think that's where that question's going, is all we don't care what the temperature is. We're gonna look at keeping what supply and return is and keeping it different. I mean, we might have it set on a 10, we might have it set on a 15 or a 20 out of the box. Okay, so that's all it's doing. Whatever you're sending out, we're gonna spin the pump up so that we maintain a certain delta T. Again, there's some information out there that's a little misleading, so be careful on that. Again, where the point they bring up is talking about the close approach, as it were, with a panel rad or something, and there is something to that, but it wouldn't really get into effect until you've got temperatures that are really, really low, like you've got your outdoor reset to the gnat's ass, and you've got delta T's dialed in the pump of 35, 40 degrees. Only something, those kind of extremes might you encounter what they're talking about. Again, if the sky is falling, the sky is falling. And again, I had it in my house for 6 seasons and I had no issues whatsoever. Outdoor reset, modulating boiler, system pump at a 30-degree delta T with a delta T responsive pump, and absolutely worked fine. So anyway, just be careful. Some people are poo-pooing things they don't have.
And or don't understand.
I've got modulating boilers and modulating pumps in my house all day long, and modulating mixing valves. If I could put it in my house and it modulated, I did it.
Yeah.
Right. And understand too, our Delta T pumps have this thing that that a lot of people conveniently disregard, called a minimum speed. It's going to only go so slow. All right. And once it hits a minimum speed, it's a fixed speed pump. So it doesn't go down to nothing, and people have to understand that.
I got to skip down to Scott's. It's jumped right out at me because we've covered this so many times. Look what Scott Jones's question is.
Oh, yeah.
And talk about the boiler pump sizing. That's because they're not paying attention to something we teach quite a bit on, Scott. So yeah, the boiler primary pump has to be sized appropriately. It can't just be the Benford 5000, as John likes to call it. That's what they like to put on these boilers. And just because it's a packaged boiler doesn't mean the boiler pump size is appropriate. So you got to be careful there. Be careful.
Right, size the pump properly for the boiler, and then put your circulator, your variable speed circulator, whether it's a Delta P pump or a Delta T pump. And the one thing no one's ever been able to fully explain is what's the difference between a Delta P pump going slow and a Delta P pump going slow. They're both going slow. So these are things I just don't understand. But anyway, hey, we got a question for Jonathan. If you're still there, Jonathan, has Runtle ever made a pressed copper plate radiator or a stainless steel one? I have an application with a drain back solar water heater that's all non-ferrous, so I just as soon skip corrosion inhibitor. Sorry for the odd question. That comes from Newt Loken. So I don't know, do you have anything like that, Jonathan?
We do have a stainless steel radiator. It's a towel radiator, however. It's not your traditional panel type radiator.
Yeah.
We are messing around a little bit with plastic, believe it or not, right now. But as far as copper or a flat steel, stainless steel radiator, nothing right now. But if the towel radiator, if that suits your need, we do have one in our hot water line of towel radiators. It's solid stainless steel that you can use potable water for, and it can be in a corrosive environment because it's not coated. It's solid stainless steel.
Excellent. Terrific. All righty. Let's see what else we got. I got to weed through some of the language here. What about pairing up a heat pump with other fuel sources? Asked Sean McGovern. Again, not giving too much away. That's called a bivalent system. And with a bivalent system, you have your heat pump, and then you have it converts to another form of heat for when it gets really, really cold. Our unit that we're going to be coming out with is not bivalent technically. It's bivalent in that it has electric resistance built in to handle those dips, but it does not incorporate, the control strategy does not incorporate a secondary heat source. That said, in Minnesota, in my home in Minnesota, we had an outdoor, an air to water heat pump that stopped. It really didn't do much below 25 degrees. So at 25 degrees, using our thermostat, we had to convert to emergency heat, which engaged the boiler. All right. So that's kind of how you get around it. It's a manual switchover. We knew it was time to switch over because the house was cold and we could hear the fan in the unit outside going click, 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 because we'd frozen up the heat exchanger. So, or frozen up the coil. So that's kind of the easy way to do it. It's not automatic, but it is the easy way to do it, if that helps. And then Richard McGrath has the line of the night. You can't go lower than low. Absolutely can't. when it comes to pumps. All right, Scott, let us know if Rick was able to answer your question, because again, we do hear that a lot regarding variable speed pumps, particularly delta T pumps. There's a lot of misinformation out there, and you gotta look at the pump curve chart. You gotta understand what it tells you, okay, and pay very, very, very close attention to that minimum speed, because it ain't going to go any lower than that. Okay. Very good. Very good.
I wanted to get back to a second for Jonathan's stainless towel bar there for a second, and you know, it just screamed right in my head right away. And I think I know why you make it out of stainless steel, and it's not necessarily to go in line with a standard radiation system in a house, but the way I look at putting one of those things in there, because why do people love to put towel bars in their bathroom? So we get warm towels, right? But that only happens half the year if you hook it up to the heating equipment.
Mm-hmm.
So I'm assuming you guys have made it out of stainless so you can hook it up to the plumbing. As you take a shower, the water goes through that and then comes out of the shower head, so you can get a little bit of warm towels out of it. Is that my assumption?
Correct. Yes, that's the premise behind that. Yep.
Sweet, sweet. I
And
love
people
it.
do it.
Yep, I love it. I suggested, you know, back in my old days in the PEX world, I would suggest to people when you're doing plumbing in the bathroom, as you feed the shower, run some PEX lines in the wall behind the mirror. But don't do it, tie it into the radiant floor, tie it into the plumbing side, so you'll get fog-free mirrors whenever you take a shower too at the same time. So, but I like that with that towel bar, Jonathan. Cool.
There's nothing better than a warm towel. Actually, in bathrooms, there's nothing better than a warm bathroom, right? Because when you're in a bathroom, generally you're what? Wet and naked, right?
If you did it right.
If you do it right, you're wet and naked in the bathroom. And I don't know about you guys. I've been cold, wet, and naked in my life, and I've been warm, wet, and naked in my life. And I know I prefer every single time warm, wet, and naked.
Now, with that being said, you may need to ask your customers if they like to be warm, wet, and naked in other rooms of their house too. So when you're doing designs, pay attention and ask that question sometimes. It might seem weird, but you might have to, yes.
Yeah, you got to maybe be worded a little differently. And I hope I didn't put anybody off for the night. You know, just there's a visual that you really don't want to take to bed with you. I'm sorry.
We are a takeaway after dark.
There you go. There you go. You know, Scott says required by the manual for the Navion at 0013. Okay, again, if that's what they're specifying, fine. Is it a 3-speed? What speed are they talking about? But again, I don't know of what pump you'll be able to put on a primary, on a secondary, on a delivery that's going to be smaller than a 0013. That's not going to encourage return water going back through the boiler. So there's a little bit more here than we can jump into at this right now. But again, we need to look at that a little bit further. Look at the numbers, look at what they're saying, and kind of see. And if Navion doesn't want to see a variable speed pump on the delivery, well, then that's Navion. A lot of others have no problem with it, and it can certainly help the overall economy of operation of it. So very good. When designing for low temps, are we looking for constant circulation? Asked Matthew Carley. I would say not necessarily. We're looking for longer cycles, longer circulation, but constant circulation to me isn't necessary. Low water temperatures and big radiators by definition means as Dave said earlier in the presentation and said very well, we're not dumping all the BTUs into the room at once and then shutting off. We're kind of, just a little bit here as we go along, just to stay ahead of the heat loss. And if we do that gently, and if we do that consistently over the course of an hour, yeah, we're going to have longer run times. Some of the rooms are going to satisfy earlier than others, or some zones going to satisfy earlier than another. So things will shut down. But as we get deeper and deeper into the heating season, yeah, we should have longer run times. Don't have to have constant circulation. Constant circulation requires, you being the world's champion system balancer, and nobody's that good. So balancing can be done with your thermostats and shutting things down. But we're going to have longer run times. Lower temperature heating needs, I think we're definitely going to have longer run times than with high temperature heating. Would you guys concur?
I would.
Good. Then I got that one right. Good for me tonight.
Yes, I mean, when you start looking at constant circulation, that's also based upon your control method, right? So if you're looking at thermostatic radiator valves, which is looking at constant circulation, yes. All right. We don't see a lot of thermostatic radiator valve style systems in the US or in North America for that matter, because a lot of homeowners don't know if they're warm or cold at 3. They need a thermostat on the wall to tell them if they're warm or cold. 3 doesn't tell me anything. I'm not sure what to do. So yeah, that's, hey,
Yeah. Jonathan, I got to believe you get that question a lot too. A lot of your radiators go in with thermostatic radiator valves. Do people call you guys up and say, I don't know if I'm comfortable or not?
All day, every day.
Yeah.
I mean, that was the tagline that I use all the time, is that, we sell radiator valves, but we don't sell a lot of them because in North America it's not used. We use them for decoration more than anything else. They're more of a hindrance. They confuse the system, but people buy them.
Yeah. Well, we were in business selling thermostatic radiator valves for a good 20 years until, I'm going to say, the early 2000s, where we sold that company because it just got to the point where it was useless. We tried and tried and tried, but it's just not how we do things here. But Alan Flankman says he loves their TRVs and constant circulation for cast iron rads. I think that's, again, you keep the pump running continuously, because, and it doesn't really need to, but you can, and then the TRVs will modulate and just adjust the flow of water through a radiator, and those work terrific. And that's why we have variable speed ECM circulators. That exact application is why ECM circulators were invented. Before, they'd have circulators running all the time, but it'd be a standard efficiency circulator, and it'd be a single fixed speed circulator. So they'd have to put in a pressure differential bypass valve, my favorite, and then have those TRVs kind of modulate down. And they kind of came across the idea that, hey, if we're going to have a pump running all the time for like 6,000 hours, we should probably have one that's a little bit more electrically efficient. Now, here in the US, we do kooky, crazy, nutsy stuff like when we have enough heat, we shut the thing off. I know, nuts, right? Crazy. But that's kind of how we do things. So the electrical efficiency part is a smaller story to be told here. But there are, as Alan says, there are instances where, yeah, you can certainly do that. Now, you don't need to have constant circulation. It certainly makes the control strategy easier, though. You don't need a thermostat to turn it on. Now, in my home in Minnesota, we had thermostatic radiator valves and panel radiators in our lower level, but we didn't have the pump running all the time. I had the pump on a thermostat. The thermostat was in the highest heat loss room, and I had no TRV on the radiator in that room. So that room was kind of like the pilot of the ship. All right, and that turned the pump on and called the boiler on. While that was going, the smaller rooms had TRVs and just modulated the flow through there. So it worked out just fine. No, you're muted there, Rick.
Matthew's got a question about, it says, how would the boiler energize using the thermostatic radiator valves with modulating pump, let's say a 0020, I think he means 6, with, let's say a SR501. Well, if the boiler gives a call, you can parallel those pumps to come on if it's pipe primary, secondary, if you have 2 pumps in the system. Or just bring the pump on with the boiler contacts. Again, the SR501, depending, you might need it or you might not, depending on how the boiler sends a signal out for its circulator to come on. maybe a little more information.
Well, we don't, yeah. So in a TRV, constant circulating style system there, Matt, that we don't actually tell the pumps to turn on because they don't shut off. All right. So in a true TRV style system itself, the circulator turns on and the boiler turns on when it gets cold out. It shuts off when it gets warm out. So that's where modulation is even more important in making sure you've got a lot of modulation, because again, it's going to turn on when it's 64 degrees outside. And then it stays on all the way until it's down to design temperatures, until, it warms up again in the spring. So it turns on in the fall and turns off in the spring. So, most of those boiler manufacturers will have a set of contacts, so hopefully to handle the power of the circuit itself. If not, then it's going to have a contact to go to an external, say SR501, to kick that pump on. So, but pump runs all the time.
We've even seen the boiler set up with a buffer tank, and what turns the boiler on is a temperature probe in the buffer tank. And it just says when the temperature gets below whatever the reset says it's supposed to be, we turn on the boiler and recharge the buffer tank. So it kind of works. And there are a lot of different ways to skin that cat, so to speak. Let's see. So yeah, outdoor reset, circulating 24/7 through the primary. Well, that'd be the delivery part. We would have the delivery part running 24/7, which again, if we're worried about circulator efficiency, having a circulator run 24/7 is kind of counterintuitive, if you know what I'm saying. So again, Dave Rick, what's the most efficient circulator on the market?
Off.
The one that's off. It doesn't use any energy then. It's really efficient. Continuous circulation would be the delivery portion, and then the boiler would simply inject BTUs into your delivery loop as needed. Under those conditions, that's when a hydraulic separator is really good. A buffer tank's even better, all right, or a short fat header. The bigger the header, the better for hydraulic separation, and then we can operate it from that standpoint. Very good. All right. In warm weather shutdown, yep, there's warm weather shutdown functions that'll shut off both the boiler and a circulator. Like I can remember running when I did a constant circulation job, I remember running it on just a warm weather shutdown control. When it got above a certain temperature outside, the pump shut off and we were done. Is a buffer tank the same thing as a storage tank? Yeah, more or less. It's just a tank with 4 holes in it. Okay, boiler in and out, system in and out,
and no coils.
And no coils. Yeah, it's just a big old tank. All right, and that's how she works. And what it does, it just adds mass to a low mass boiler.
And we actually covered off buffer tanks in week 1 of the winter.
Right. Go back and check that out.
The link for that, Stephen, let me know. I can easily send that out to you. Shoot me an email. I will have to dig it out and get it over to you. So let me give you my email address. Oops, sorry.
There he goes. All right.
And if anybody else has any questions after the fact too, you can always send me an email. Or John, you'll get the email technically from John tomorrow night.
Right.
Or Rick too. If you know Rick's email, I'm sure won't mind taking your questions either. I think anyway, right, Rick?
Take them as they come.
There we go. Hey, I'm gonna get a link to that recording if you want to hang on. If you guys want to take this question from Sean about utilizing buffer tanks as hydro separators, it's a pretty easy question, so I know you guys can handle it. Because I know the answer. I know you guys know the answer. I'm gonna get a link to that buffer tank presentation, and I'll just throw it up for everybody.
Sean, as far as using a buffer tank as a hydro separator, it accomplishes that function of keeping the circulators from affecting one another, depending on how it's piped. A lot of times you'll see buffer tanks with a 4-pipe configuration. You don't have to pipe them that way. You can pipe them in a 2-pipe or 2 inlet or a 3 inlet, but most people just kind of get their arms around the 4-pipe configuration. Now, there's times when using alternative energy sources and stuff, you might want to pipe it in a 3-way configuration, but it does accomplish what we're trying to do. And it's, if I've got a boiler circulator, the primary circulator that's pumping into the buffer, then as it goes into the buffer, it loses all its velocity. It loses its ability to affect anything on the secondary side of the system. So the secondary side of the system's got a system pump or a series of zone pumps or whatever. So you won't be affecting them. You'll take those, you'll decouple those, or you'll hydraulically isolate those, so you get one and the same with that. Again, the buffer tank's there if you need it. If you got a bunch of smaller zones that aren't going to give you the minimum runtime that the boiler manufacturer typically wants, about 10 minutes as a minimum runtime. So if you got little tiny zones that might not give you that, then you want to consider that. Or there's people that make higher mass condensing boilers where it's not as big of a deal. So you can look at that a couple different ways.
Yeah, your buffer, as Rick said, your buffer tank's just a big hydraulic separator, really, more than anything. And when you have, again, I might have to answer the question Rick just did, so I'll just shut up.
Well, I'm not sure. He might be asking a little bit different. He's looking at, it's not necessarily a buffer tank, Fairbanks. I think you're thinking of a storage tank with a tankless water heater, because he's asking for water heater, not boiler here.
Oh, okay.
You were going through buffer tanks as in tied into a boiler and your heat emitters, but Fairbanks, if you're talking about it as a water heater and storage, if I think that's what you're talking about.
Okay, there we go. I'm sorry. Maybe I misunderstood the questions. Yeah.
I'm sure I did too.
Yeah,
because you used the word buffer tank, but maybe you're looking for more storage. I think I think that's where you're going, Fairbanks. Let me know if that's what you were talking about. You tankless water heater and a storage tank using for your domestic in a structure, domestic hot water out to a structure, if that's what you were thinking of. So just let me know there. Excellent.
Are there any guidelines for maximum hot water temperatures for floor heating in concrete slabs with respect to avoiding thermal induced cracking of concrete? I think all three of us are uniquely qualified to answer that question. So I'll defer to Dave and Rick, because we taught this stuff for how many years, guys?
I was there 15 years. Yeah.
I was there 12. Rick?
Well, I worked for them 7 years, but sold their product for over 20. So.
Yeah, we're all ex-Upanorians. Yeah. So if the three of us can't answer that question, we wasted our youth. Dave,
well,
we're going to go to you first.
Yeah.
Oh,
go ahead.
Rick, why don't you go
ahead? Rick, he was talking. Go ahead, Rick.
Well, as far as the 150, it was really hard to ever find anything, because it wouldn't be typically from a tubing manufacturer. It's going to be from the concrete industry to talk about, the maximum temperature going through there. But the expansion and the cracking is usually more, well, it's not a wives' tale, I won't say that, but you have to be able to slug that concrete with a whole bunch of energy. And I don't mean temperature, I mean energy. And what I mean by that is BTUs per square footage of area heated. And I'll just throw some random crazy numbers out there. Where you might worry about thermally shocking a slab is, say I've got a small snow and ice melting entryway into a commercial building, right? Let's say it's 1,000 square foot, but I have the possibility of that system, because it's tied into a boiler that's 10 million BTUs. You see what I'm saying? You've got to have an extraordinarily large amount of BTUs to focus and concentrate on that relatively small slab to ever worry about thermally cracking it based on a big slug of energy. So, people have said, well, you put that radiant floor in, my slab cracked. What most concrete people will tell you, there's two things you can always guarantee about concrete. It's going to get hard and it's going to crack. And most of the time, it absolutely has nothing to do with the tubing that's in it. Now, there are some exceptions, but the majority of times it has nothing to do with that. These are just ways of people wiggling out of bad work and not understanding the characteristics and stuff. And unfortunately, I was involved in some, not personally, but had to write letters and people are suing or not paying because they were worried about their crack slab. And it's just, I mean, I could probably go back and find my notes to show you. You just look at, the specific heat of concrete and how long it takes to bring something up to a point of where you could crack it. I won't say it's completely nonsense, but it's somewhat hypothetical, and I wouldn't worry about it so much. Now, there's good principles to stay with. I think the number we stayed with most of the time, and I've never seen it in writing, and I've been out of that end of things for a while, but I think it's generally speaking, it was 150 degrees on a slab, a 4-inch, 5-inch, 6-inch slab. When we start talking about gypsum or lightweights or thinner slabs, it was 140. Okay, if it's embedded tubing in, what we call a wet application, if we get into a dry application, there's usually no worries about that. Manufacturer will normally tell you, but 150 or 140, or generally speaking, for wet applications, the maximum supply water temperature you'd want to use.
I've learned a good saying from many, many years ago is it's really, really hard to thermally shock a slab.
Yeah.
You can surprise it, but it's really hard to shock it.
Yeah.
The slab has to be dead cold, and then you slam super hot water into it, which is a very, very rare occurrence in the real world. The only time it might happen would be on startup. So you do want to gradually bring that slab up. Yes.
Let me clarify something there.
Mm-hmm.
Not just the temperature, because what naturally happens to the temperature, even if it's hot. Say you open up a valve and you send 180 out there.
Mm-hmm.
What does it instantly turn into as soon as it hits the slab?
It transfers and it gets cooler.
It gets a lot cooler. So you've
Right.
got to have a lot of BTUs and a big delta T to ever closely approach, getting, what do you say, not shocked, but
you can surprise it a little.
Surprise it a little bit.
Shock it, yeah.
So again, it's almost a fallacy. It's almost like, guys, people have taken that and run with it.
And all of this goes away if the concrete slab is installed properly with control joints, expansion joints, control cuts. The way slabs are kind of supposed to be done, whether there's radiant in there or not. This goes back to the hardwood floor discussion that we've had many, many times over the years as well.
Yes.
It's the same thing, only different. I hope that answered the question, because it's a good one. That's a really, really good one. Okay, what else do we have up here? Yeah, no. Okay. Newt's been looking at the Taco Dimplex air source to water heat pump. All right, attaboy, Newt. Let's see what we have here. We can sell a job that utilizes environmental energy, solar heat stored in the air, indirect solar, and is operated at least in part by our solar electric system and direct solar radiation. This is a low carbon approach, and if the electric and gas grid goes down, our systems can still deliver heat and hot water to customers' houses from on-site sources. That's added resilience and worth paying for. Yeah, I absolutely agree. The heat pump doesn't care where the electricity comes from, right? Nope. Doesn't care. You can put a hydroelectric dam in your backyard. I had a buddy who did that. He had a river in his backyard, and he made a hydroelectric dam, and he created enough electricity for 6 houses. He was a nut, but this is what he did. But yeah, I absolutely. I mean, there's the potential for air to water heat pumps, and in our case, it's air to water, so we could do low temperature hydronics, but we could also do air to water to air using a hot water, using a fan coil or hot water coil in existing ductwork. So there's that retrofit application. As long as we take real good care of identifying the projects and making sure that the envelope is appropriate for the output of the unit, this is one of those things that's kind of like, duh. It's almost it has to be done properly. It has to be understood, but the benefits of it are significant, I think. And well, we finally did get to the question here. Let's go. Where are we at here? Any chance the TD heat pump would have, let's see, some ductless heat pumps have an adjustment to modulate the electric draw off the maximum. Any chance the TD heat pump would have that feature on board so it's easier to set back for off-grid operation? I think we had a lengthy discussion about that exact issue, didn't we, Dave, when we were down in Florida?
Yeah, and I don't remember, unfortunately, too much of it, and I'm trying to do my homework right now on that. So, Newt, I don't have that answer and for you there about the electric immersion that we have built in. I think that's what you're asking about.
Or just where I think he says will it work with off-grid heat or off-grid electricity? And yeah, there are setback functions built into that. And again, I'll tell everybody right now, we're learning the control strategy of that thing, and the control strategy and the built-in control panel is extensive. And there's a lot of interesting stuff there that we're just scratching the surface on. So I don't know if we'll have that answer for you next week, Newt, but I'm hoping we'll have that answer for you by the time June rolls around when we have these things ready to go. But that's a good question, and we will take note of this and make sure we include it in our discussions. We have a session with the manufacturers on
Friday.
Friday, yeah, on Friday. That's right. All right, here we go. You're right, Richard. Absolutely. All right. As long as you have hot water, you can do anything. There you go. Are mod cons being used on hydro air systems? Yes, absolutely. Anything that requires water, hot water. Yeah, you can use a mod con boiler on that, whether it's an air coil in some ductwork. That again, that was the other half of my heating system back in Minnesota. The lower floors had panel radiators and some radiant floor. The upper floors we had an air handler, and we used the existing ductwork upstairs for forced air heat upstairs, and it worked out fantastic. Absolutely fantastic.
Yes, I mean there are fan coils, hydro air coils that are they're going to be rated again for 180. And if you've got a particular manufacturer, particular installation of a job site, and you're looking to put in a mod con on there, it doesn't need to be at 180. So take a look at the heat loss of the room, what the air handler that's there, and talk with that manufacturer or find their paperwork and see what the heat output is at lower temperatures. There are also a lot of fan coils out there, hydro coils that are designed for lower temperature, which that are out there. So there's some out there that their maximum designed to water temperature is 130. So you've got a lot of surface area that it's going to have out there to do that heat transfer. And as I was going through the presentation tonight, that was the one thing I forgot to discuss was air coils, hydro coils. I thought about it 3 times over the last 2 weeks. I'm like, oh, I got to put that in there, but I wasn't sitting here when I thought of it. I was someplace else driving in my car. So.
Very good. Rich says a 1.5 ton.
All night tonight. Yep, just like I did all night tonight. Do that also with your fan coil that you have there.
There you go. Yeah, 1.5 ton fan coil at 140 degrees will work awesome in a tight house requiring low water temperature. So much of what's going to make the heat pump work is tightening up the envelope, and there's an entire industry out there of folks that their business model is to tighten up the envelopes of homes to lower the heat load. And when you lower the heat load, now heat pumps become more and more practical, where we're hearing stories of people putting in heat pumps with no backup at all down to where it's 0 degrees out, because they've done the math, they've done the work, they know the heat load down to the number. It's not a pie in the sky exaggerated number to be safe. It's a real number. They did a blower door test. They understand the science of that building, and they're able to design a system that perfectly matches that load. And when you do that work, all right, all of a sudden, it's not a race to the bottom for the lowest price. It's what value do you bring to the table, and how do you enhance the performance of the house and give that customer the efficiency that they're looking for. And the other nice thing about it is utility after utility after utility has scads and scads of rebates available and incentives available to do this work. I was looking at the Massachusetts site just the other day. $10,000 goes for a $10,000 not a grant, but an incentive rebate towards the installation of an air to water heat pump, provided that the house assessment and has been done first. So I mean, they're giving you the money, right? The money's there to be had. You just got to go ahead and do it. Very good. All right. Is Jonathan still with us?
Yes, I am.
All right. Hey, any last words you want to give to our group about Runtle? I think we got off on a little tangent there, and we do that sometimes, Jonathan. I'm sorry, man, but
No, it's cool.
any last words you'd like to share?
No, you guys covered it well. It's a product that integrates really well into what you're talking about. I'm looking forward to next week because that is something we're interested in as well. Runtle is appreciative of these opportunities. We're a local manufacturer. We believe in indoor air quality, efficiency, all those things, and our panel radiators and some of our other newer products that will be coming out integrates really well. I appreciate the opportunity.
Well, awesome. I think we'll be making beautiful music together going forward.
Yes,
so really appreciate you being with us, John, and thank you for being willing to answer some questions. It's nice to have, it came straight from the horse's mouth, so to speak. So I know our guests appreciate it, and we certainly appreciate it as well.
Thank you all very much.
All right, thank you.
Good night.
Take care. And throw out a last roundup for any questions you guys might have. We've been at this 2 full hours now, and I don't know about those two guys, but I'm getting closer to my bedtime. I get awful crabby if I don't get 14. If I don't get 14 hours of beauty sleep, I get awful crabby.
Well, I guess you didn't get 14 hours last night, so that quality beauty sleep I can see.
Well, it's beauty sleep. I use that term loosely, I guess.
I'm all coffeeed up and wired for tonight, so.
Good man.
I got a little bit to still wind down afterwards, so I will. I didn't have a drink with me tonight, so that will be right afterwards.
And for Rick, it's not even 6 o'clock yet. You haven't had dinner yet, have you?
6 o'clock. Yeah, I had a snack before we started, just knowing that this can go on sometimes. But look at me, I'm not starving.
None of us are. None of us are. All righty, folks. Hey, thank you so much. Really appreciate the gift of your time this evening. And congrats to all of our winners. We love giving stuff away, so we really appreciate you guys taking part in our little trivia contest. And if you're ever in downtown Boston, go down to the Common, right down to Beacon Hill, and you can stop in at what is now Cheers, but boy, it used to be the Bullfinch. And if I'm there, I'll tell you some stories, because in my youth, boy, we did have some one evening in particular, and I'm just going to let it go because I don't need another installment in my HR file, so we'll just let that go. Everybody have a great evening. Thank you so much for being with us, and we will see you next week.
Next time. Thanks, everybody. Greatly appreciate you.
Goodbye.